Okay, we're going to quickly go through the review for this unit, Unit 6. And I'm just going to go through every single question since I don't know exactly where everybody landed on every question. I'm not going to go through all of the solving, and I'm not going to get you the final answers for a lot of these, but I will go through the setups on them, and then hopefully you can go through and solve the final equations. So on any shape, to find the number of degrees inside of a polygon, we're going to use this formula. And I believe we're going to use that formula on, most of the questions on here, or quite a few of them, I should say. But that n minus 2 times 180 finds you the total number of degrees inside of any polygon. Since this polygon has 4 sides, 1, 2, 3, 4, we can just plug in a 4 for n. So 4 minus 2 times 180. That equals 360. And at this point, hopefully we've got that memorized for just a 4-sided shape anyway, that its interior angles add up to 360 degrees. Then I just took all of those angles in there, including x, and put them into an equation, set it equal to 360, and at that point you can solve for x, and then you're done with the question. Let's go to number 2. Check it out. We've already got that formula again. So it says find the sum of the interior angle measures. That is exactly what we're talking about here. The sum of the interior angle measures is that formula right there. And then it says of a convex nonagon. A nonagon is a 9-sided polygon, so all we would have to do one more time here is plug in our 9 for that, n minus 2 times 180. And I'm not going to solve that for you, but you could plug that in on your calculator and come up with the sum of the interior angle measures for that one. Number 3, this convex polygon has 7 sides. So using that formula, I've determined that we have 1,260 degrees inside of that shape. Although now I'm noticing that I did it wrong. It says 7 sides, not 9 sides. Let me fix that really quick. That should be a 7 minus 2 times 180. And that number is probably way too high now. So I'm going to have to go back to my calculator one more time. So we should have 7 minus 2 times 180, and that would be 900. Don't know where that 9 came from, but that's okay. 775 plus x equals 900. I got that 775 from just adding all of those numbers together inside. So all of these here I added together. You can check my work on that one too, because obviously I made a mistake, and so you never know. Maybe I added those incorrectly, but you can check my work there, and then you just add on x to that, set it into an equation, and you're good to go. Oops, let's do this instead here. Number 4. Says find the measure of each interior angle and each exterior angle as well of a regular 15-gon, a 15-sided polygon. So interior angles, like we've already stated a couple times, interior angles would be this formula. So if I plugged in 15 to that, I got 2,340. Each exterior angle, that's pretty simple. You can just do your 180 minus your 156 that we got from this one. I just divided by 15 there. But you can use that 156 to figure out your exterior angles are all 24. Another way to do this question, since all of your exterior angles add up to 360, you could divide 360 divided by 15, and I bet that gives you 24 as well. So that's just another thing that you could do to get that exterior angle. One more comment on that if you're confused. It says regular here up at the top. Regular means all of the sides and all of the angles are the same, and that's why we can divide those like we did. All right. This question is typically our most missed question. I said that when I taught it the first time. It says the measure of each interior angle of a regular polygon is 160. Find the number of sides. Remember, I said you kind of got to think outside the box on this one, and I meant that literally. If your interior angles are all 160 degrees, that means your exterior angles would be 20 degrees because they should add up to equal 180. Then, if they all are 20 degrees on the exterior, well, all I would need to do then is divide 360 by 20, and that gives me a total of 18 sides. If you are stuck on number 5, you need to look back at this multiple times. Just because I've given you the answer, and that goes for every question on this review, just because I've given you the answer to it doesn't mean you know how to do it, and it doesn't mean that you'll be able to remember it. when that test comes. So we need to understand what's happening here. We found our interior angles first. Well, it was given to us, I suppose. Well, then we found our exterior angles, and then we were able to divide by 360 to get our number of sides. That's a tricky one, though. Number 6, it says in the square below. Square is important. Let's start there. A square means that we have two properties that are true. Our diagonals are congruent to each other, so the length from here to here is the same as the length from here to here. That's our rectangle property. But then also, parallelogram properties state that our diagonals bisect each other. So that's bisected, and since these are all the same, we can mark it like that because the diagonals were congruent as well. So all 4 of those pieces are the same, which means this is 13, 13, 13, and 13. Which also means if we're trying to find BC here, we're trying to find this. We've got a triangle here that's isosceles with 2 congruent sides. We've also got a 90-degree angle here because our rhombus property says that a square, I guess the diagonals are perpendicular, and the square has the properties of a rhombus. So if that's a right angle and these are both 13, this actually becomes a 45, 45, 90 triangle. So that's just a rule for all squares. They all have 45, 45, 90 angled triangles in them. And so then we can use our 45, 45, 90 rule to say if those are both 13, then this is 13. Try that again here. 13 root 2 for the hypotenuse. Remember, on a 45, 45, 90 triangle, it's x, x, x root 2 on our template. So that's where I got the 13 root 2 from. Continuing here, we have a convex polygon, having trouble talking. A convex polygon with 5 sides. So this polygon has 5 sides. I immediately went to our formula once more, and I've determined that the total number of degrees inside of the shape is 540. Using that 540, I could say, well, the total of all of these things that it gave me, including that one, the total of all of those together would be 8 x's total, and then minus 12 regular numbers. And then if I set that equal to 540, which we solved for already, you could solve for x, which is what the question's asking for. I didn't do that for you, but you could do that on your own time. Number 8, quadrilateral ABCD is a trapezoid. M is the midpoint. I marked that by showing here and here that it's a midpoint. And then on the other side, N is a midpoint as well, which I've marked with double markings. I just wanted to state one more time that MN is a mid-segment. That's a vocabulary word that we use. That length from M to N, if you look at the picture, is a mid-segment. My rule for mid-segments was 2 of these equals the top plus the bottom. So 2 of those times 2. 2 of those would equal this plus this. And that's exactly what I wrote down there. 2 MNs equals AB plus DC. And then I plugged it in, and I'm going to let you guys solve. But don't forget when you solve here that you will need to distribute. You'll need to use the distributive property before you can finish solving. We're going to go through some properties here. So it says, which of the following quadrilaterals is a parallelogram? Select all that apply. So let's just start with the rectangle. Select the true statement about a rectangle. I'm looking at number 10 here. Going through my options, I've got diagonals are congruent, but it says only congruent. So that's the only thing. Well, on a rectangle, I do know diagonals are congruent, but I'm not going to say right now that that's the only thing that's true. I'm going to read all of them. Diagonals are perpendicular. This is a rule for a rhombus. I'm going to write these down since we know where they came from. Rectangle, rhombus. Next one, diagonals are both congruent and perpendicular. Well, if diagonals are congruent, that was a rectangle property. And if they're perpendicular, it's a rhombus property. So this is true for a square. And then it says on this one, diagonals are neither congruent or perpendicular. Neither congruent or perpendicular. Well, that would be not a rectangle then. And also, that's supposed to say rectangle, not a rhombus. There might be more of these that I haven't got to yet. because I know that there's actually some other shapes that are diagonals are congruent and perpendicular, but we'll get to them when we get to them. So select the true statement about a rectangle. So on a rectangle, of the options up there, we have it listed with A. So let's call it A for the first one. Next one, it says select the true statement about a rhombus. Like we said up top, that was B. Select the true statement about a square. We had that listed as well. We'll call that C. That had one of each, one from a rectangle and one from a rhombus. Then it says select the true statement about a trapezoid. Ooh, a trapezoid. If you remember, a trapezoid, we don't have a ton of rules about trapezoids. We really only have the one where opposite sides, just one pair of opposite sides are parallel. So I don't think any of that up top is true. So we'll have to go with D, where it says really nothing is congruent or perpendicular. Isosceles trapezoids are a little different though. Isosceles trapezoids are the ones that are symmetrical, where that's congruent. Everything right down the middle here is my dashed line. That is completely symmetrical. And we said since it's symmetrical, we know that the diagonals would be congruent to each other. The length from one to the other would be the same. So that one works for A as well. Diagonals are congruent. Diagonals aren't necessarily perpendicular for an isosceles trapezoid though. And it says select the true statement about a kite. And again, if you've ever built a kite, you know that when you put those wooden rods together to make the kite, I did a bad job of drawing it, but those should be perpendicular, which is the same rule as that rhombus rule, where diagonals are perpendicular. So I'm going to write B for that one too. So this one is also kite, and this one is also isosceles trapezoid. Regular trapezoids don't have a ton of properties, so if you see just the word trapezoid, be very cautious. The only thing you know about it is that you've got two sets of parallel sides. I'm sorry, one set of parallel sides, actually. Number 16, a rhombus has a length of 16 centimeters for BD. I've separated that into 8 and 8 here. 8 and 8 instead of writing a 16. And then it says AC is 8. Well, I separated that into 4 and 4 on this. So that length AC is a total of 8. Next, it says we are trying to figure out AB. Sorry, I couldn't see it. We're trying to find that length, the side length of that rhombus. Well, to do this, you may have forgotten that we said the diagonals are perpendicular, which makes a right triangle. And we should be really good at right triangles by now. We've done plenty of them. So we can use the Pythagorean theorem for this one. Since we're finding the longest side of the hypotenuse, that means I'm going to use my addition shortcut. So this would be 8 squared plus 4 squared. And if we do the math on that, that looks like we have 64 plus 16, which happens to be 80. So the square root of 80. I don't know the last time we've gone through this in class, so I will quickly go through simplified radical form for this. I'm looking for perfect squares that go into 80. And if I'm not mistaken, 16 does go in 5 times. So we separate it like this, and then the square root of 16 is 4. The square root of 5 is a part of our answer. That actually is going to go there. Any of this is fair game for the test, though, so you need to be able to do any of these questions. Okay, doing the next one. This one should go pretty quick and easy. With a rhombus, I'm just going to quickly go through what the rule stated. We can separate, or I guess bisect, these angles with the diagonals. So if that's 55, so is that. This is 55, this is 55. So those are all the same. And then if I wanted to go to these ones down here, which are also bisected, knowing that this is a 90-degree angle, you could say 90 minus 55, I'm sorry, 180 minus 90 minus 55. The triangles add up to 180. You would get 35 for this, and this, and this, and this. So each of those are 35 degrees. I don't even know what the question's asking for down there. I'll let you guys figure out what those specific angles are. But we've got everything we need filled out on the top. That was the last one on that page, correct? Yep, that was 17. Let's go to 18. Does the given property prove the quadrilateral is a parallelogram? Or in other words, is this one of the 7 that we wrote down? The quadrilateral has 2 pairs of congruent angles. I'm going to say no to this because that one does not say the word opposite in it. You need to be looking for that opposite word. They need to be opposite angles that are congruent. The quadrilateral has 2 pairs of congruent opposite sides. There you go. That one's correct. Next one, the quadrilateral has 2 pairs of congruent opposite angles. I like the way that that one's stated as well. The quadrilateral has diagonals that are different lengths. That's not something we've ever said, so no. The quadrilateral has 1 pair of opposite sides that are both parallel and congruent. That works. Okay, number 19. Looks like I've got the formula here for how to fill out X, or how to find X. These are bisecting, or the diagonals are bisecting each other, so this would be equal to this. Then it's looking for NJK and NKJ, and for both of those, you're just looking to use alternate interior angles. So if this one down here is 50, if I do alternate interior angles, that means this is 50. And if that's 63 using alternate interior angles, this is 63. And that should help you solve that one. Number 20. Given the figure below is a rectangle, EBC is 59. I've already got that written in there. And then AE is 4x plus 6, and then it gives us BD, which is the full length here. But I'm not going to write that in. Okay, I'll write it in. 5x plus 33 is that full length. So let's find the following. Well, I'm not going to go through all of this with you, but I will tell you that these are a 90-degree angle, so that'll help you find this one. And then remember with rectangles, if that's 59, this is 59, and then over here, this is 59, and this is 59. And then you guys can find these missing angles there because all of those would be 90 degrees in the corners. And then for the side lengths, 4x plus 6 only goes halfway. That's like a half of a diagonal. So if I doubled it, it would be 8x plus 12. And that I could set equal to 5x plus 33 and solve for x there. Once I solve for x, I can plug it in to find EB, which, by the way, EB is a half of a diagonal if you look at the picture. So I would plug it into our half diagonal over there with the 4x plus 6. Number 21. For the rhombus below, find the measures of the angles. If this is 36, I love a rhombus question because I know this and this and this, like we already talked about, and these are 90 degrees, which would help me find this, which is the same as this and this. And I'm not going to finish solving that one for you either. You guys can do that subtraction to find angle 2. Okay, another question about properties. For each of the following quadrilaterals, select the properties that must be true. So we're just looking at a rhombus, and we're saying, are these true for a rhombus? Are all sides congruent? Yes. Are there 4 right angles? That's not something we've talked about with a rhombus. Only 1 pair of parallel sides? Nope, a rhombus is a parallelogram, so it has 2 pairs. And then it says 2 pairs of parallel sides? Absolutely. Rectangle, all sides congruent? No, not necessarily. 4 right angles, that's one of our properties. And then I'm going to say there's 2 pairs of parallel sides for that one. Parallelogram, I'm going right over here right away and saying that we've got 2 pairs of parallel sides. I mean, it's in the name, parallelogram. And then other than that, we don't really have anything else that we know for sure to be true on every single parallelogram. On a square, square has everything that a rhombus has. It has everything that a rectangle has. And also, we've got 2 pairs of parallel sides. On a trapezoid, we've got 1 pair of parallel sides. I'm not going to say anything else about it, especially since this is that just plain trapezoid. It's not even an isosceles, so we don't have any other properties. I guess I should have done a check mark there. But that's all we know. It's got 1 pair of parallel sides, and that's it. A kite doesn't have any parallel sides whatsoever. It's got no right angles. I guess some of them do, but not. I mean, most kites don't have any right angles, and most kites don't have any sides. I guess all sides congruent. So kite, I don't really have anything I can write down for that. Determine the name. This looks like just a trapezoid. If it was isosceles, we would need those marked. We don't have that. So I'm going to erase those here quick. Next one looks like a parallelogram. I know because opposite sides are parallel, both sets. This looks like a kite to me because our consecutive sides, two pairs of consecutive sides are congruent. This one looks like a rectangle, a square, excuse my handwriting here, and then a parallelogram. Using our property that we have one pair of sides that are both congruent and parallel. Last one I've already kind of got set up for you. We've already done one similar to this, but I can just kind of show you my setup. 540 is the total number of degrees of this shape. So then when I set up my formula, I just added all of those things together inside and set it equal to 540. Number 25 was that most missed question again. And I think I listed both of these questions twice on the review because even though they show up once on the test, they're typically the most missed questions. So again, with the number 25, it's giving you an interior angle and asking for the number of sides. That means you need to find the exterior angle and divide from 360. That looks like it for this. I would use the rest of my time to finish them up, get 100% online, and turn it in before the test. This video, if you want to look at it later, if you wanted to watch it again, I will put it up on Canvas for you to watch. It'll be under the modules.